So your domain and range that you should get, again, your domain is going to be 0 to infinity. Your range is going to be negative infinity to positive infinity, or y is an element of all real numbers. So that is for any base log function. Whether it's natural log, log base 10, log base 3, doesn't matter. They're going to have that domain and range. Okay? Then on number 3, we graphed 3 different ones. So ln was kind of a little bit taller than log 3, and then you had log base 10 of x. This is really, really important when you do transformations. Your parent function side is always going to have the point 1, 0 and the point b, comma 1. So whatever your base is, comma 1. So like if you were to come down to number 4 and you wanted to draw, like, and do your transformations, your left side, log of x is the same thing as log base 10 of x. So that means our points in our parent function are 1, comma 0, and your base is 10, so 10, comma 1. If I wanted to do log of 5x, we said that that was a horizontal compression by 5. So when you go to change your x values, you need to change what your x values are. So if it's a horizontal compression, that means to go from our original x to our new one, we're multiplying by a 5th, or you're dividing by 5, however you want to think of that. What's up, Queenie? Yeah. And then in this case, your y values didn't change. So instead of having the point 1, comma 0, you have the point 1/5, comma 0. Instead of having the point 10, 1, you have the point 2, 1. You would plot those 2 points, and then that would help you to graph your graph after that. If you did the 1/5 x, the other one, that's a horizontal stretch, you'd multiply by 5. So you'd have the point 50, comma 1, and you'd have the point 5, comma 0. Okay. Again, this was moving you left, right. This one was reflecting and it was moving you left or right. So if you were going to tell me what the transformations were like on these ones, like if we wanted to do our original log x and we wanted to do this one right here, so log, negative x minus 5. We would say that those transformations, you're going to have a reflection over the y. And then again, when you're deciding left, right, if you have negative x minus 5, you have to factor out that negative because that negative has to apply to everything. So this is the same thing as negative x plus 5. And you have to rewrite it that way. So we're not really going right 5. This is actually moving you left 5. So then your base points, again, are the points 1, 0 and 10, 1. So to go from our original x to our new one, we need to reflect it, which makes that negative. And then if we're going left, that's subtracting 5. So it ends up looking like that in this case. And then you would plug in numbers. So if you take 1 and you plug it in, negative 1 minus another 5, that gives you negative 6, comma 0. If you plug in 0, all right, you still get 0 minus 5 is going to give you 0, negative 4. Oh, no, this doesn't change. I'm lying to you. Oops. Negative 4, comma 1, because we're not changing our y. So you plug in 0 right. Oh my gosh, no, I can't add or subtract. Third time's a charm.
Is that 10-1?
That's 10-1, yeah. Sorry. Okay, so take 10 and plug it in. You get negative 10 minus another 5 is going to give you negative 15, comma, the y doesn't change. I wasn't even in the ballpark the first 2 times. So your y's aren't changing, your x's are. And then the last one, you would be changing your y values, not changing your x values. All right. The last thing we're going to talk about is the challenge question real quick. We're not going to go way in depth with it, but I am going to show it to you guys because I'm sure it'll come up on a quiz or a test. So you know that e of x, we've talked about that. That's an exponential function. And so it wants you to let the inverse function be L of x. So if you have an inverse, it's always going to take your domain and range and it's going to flip-flop them. So question A says, what is the domain of L of x? What is the range of L of x? All right, so that's taking them and just flipping them over. So if this was our domain, that means our domain becomes 0, infinity, and your range becomes negative infinity to positive infinity. So those two flip-flop from inverse to original. Domain and range flip-flop. Okay, so if f of x is e of x, the inverse of that is the natural log of x. So those are opposites of each other. So you have your exponential e of x, you have your logarithm, which is natural log of x. So again, if you go back to what we were just talking about, you're always going to have the point 1, 0, and then you're always going to have the point b, 1. So if it asks you what is L of 1, you're going to have that point 1, 0. If you wanted 2, you'd have to plug into your inverse equation. In terms of compositions of functions, I have no idea why it's asking you this because we haven't done this since like unit 1. But remember, if you compose original and inverse, you get x. So basically, if you take one and you plug it into the other, everything cancels out. So like if I take ln of x and I plug it in for e of x, I would get e raised to the natural log of x. The e and the natural log would cancel each other out. If I plugged it in the other way, so if I took e of x and plugged it in here, I would get the natural log of e to the x. Again, the natural log and the e would cancel each other out and you'd just be left with x. Your inverse, again, you should just know what it is. You shouldn't have to go find it because it's very, very basic. And then, so just so you have them both, so e of x looks like this. So that's e raised to the x power. ln of x looks like that. So remember that y equals x line goes right through the middle of them and it reflects over top.